Welcome to another episode of Gaming Performance. I'm your host. I've returned with a Super Saiyan 3 event in years of research and finding out the root cause, not just chopping branches off a tree, but the actual root cause of the latency problem on PC and playing games. So let us begin. I'm going to get to the core of it. I will tell you that I have determined that there were two files in Windows that goes back decades. Please make a note that I do use Windows 11, so I don't know if the current version of Windows 11 still implements these two files that you will find in Task Manager. However, those two files are CTFMON.exe and TextInputHost.exe. Now, if it was as simple as right-clicking on them and stopping the process and deleting them so they don't continue to operate from the Task Manager, and I've tried to do so, it would be a shorter video than this. However, that's not the case. You're going to have to open up something called Task Scheduler, and you have to type it in while you still can, because right now you still can type it in the text box and bring it up. Once you do, you're going to go to, without having to execute this particular code, you can go to Microsoft, Windows, and there's something called Text Service Framework, and within Text Service Framework, you're going to find something called MSCT Monitor. You're going to right-click it, you're going to stop the process, and you're going to disable it. Reboot your PC. When you reboot your PC, you will not be able to use the search box at the lower left-hand corner right next to the Start button, or if you're on Windows 11 in the center. So that's going to stop working. You will not be able to use dictation anymore. However, there are other services that allow you to do that. That's not in this video, but I do want to discuss with you why that's important. And that is because it is the root cause of all latency in Windows and the entire Windows environment for the last few decades. I'm going to read to you the following: how far back this issue goes. The root of this input latency stretches back over 25 years to the release of Windows XP 2001. Originally, CTFMON.exe was introduced to handle the text service framework, specifically advanced input like speech recognition, handwriting, and Asian language input method editors, or IMEs, and it shows you an example of that. With the launch of Windows 10 and Windows 11, Microsoft updated this architecture. They integrated it deeply into the Universal Windows Platform shell and introduced TextInputHost.exe to manage modern UI elements like the emoji panel, cloud clipboard, and touch keyboard. What started as an optional accessibility tool in 2001 became a permanent mandatory layer of modern Windows desktop environment. How it creates a parallel coding path. In a complete optimized bare metal environment, game input follows a clean linear path, and it shows you an example of that. When CTFMON and TextInputHost.exe are active, Windows forces your input to take a parallel coding path. Instead of your peripherals talking directly and exclusively to your game, the Windows kernel splits the signal, and it shows you how the signal is split, and it completely explains the additional latency. This right here, this is the inconsistent additional latency that is created by those two files. Now, the mechanics of the parallel path. Thread injection and hooks. TextInputHost.exe utilizes low-level Windows hooks, and this forces the OS to send a copy of every single input packet to the text service framework before or simultaneously as it reaches your game. That creates latency. Context switching jitter. Because this input watchdogs run a separate user mode process, your CPU must consistently perform constant context switching to let CTFMON analyze the input. Even with the high-performance processor, this switching breaks the predictability, streamline execution your game engine expects. The buffer interruption. If you use high polling rate peripherals, the parallel path gets overwhelmed. The text service framework wasn't built for high-frequency gaming data. It gets bottlenecked trying to process thousands of input per second, causing deferred procedural calls, queues to back up, and create a mushy input response or sudden micro stutters. By disabling these services, you collapse this parallel split, which is up here. You close down the secondary track entirely, forcing the Windows to treat your input as a single uninterrupted line of raw data sent straight to the gaming engine. Now let's talk about network card and the monitor. When you run custom scripts to kill the parallel coding path of the CTFMON and the TextInputHost.exe, you aren't just fixing your mouse or wheel input. Because of how the Windows kernel queues work, removing these input watchdogs triggers a domino effect that directly stabilizes monitor frame pacing and network packet handling. To understand why, you have to look at how Windows prioritizes tasks. When a device, like a graphics card or a network adapter, needs attention, it sends an interrupt. If the CPU is stuck dealing with the massive queue chain of parallel user mode service like the text service framework, it delays everything else. Here is exactly how stripping these files down directly affects your monitor and your network adapter. And it explains the input there. I don't want to read all that, but I'm going to leave it on screen so you can see it for yourself. But basically, you see without optimizations, the CPU processing frame goes to interrupt from the text input host wake up, then to the frame delay, monitor miss, sync, stutter, and it equals stutter. But with the optimization bare metal approach, the CPU processing frame goes to clean render, a perfect frame delivery, which equals smooth. I'm gonna get down to the gist of it. The result on screen. On paper, your FPS counter still reads high 200 frames per second. In reality, the spacing between those frames become uneven, unstable frame pacing. Your monitor receives 2 frames smushed together, followed by a tiny gap. This is what creates that visual hitch or floaty display lag during fast camera pans or tight corners. Even though your hardware is top tier, by killing the text host, you ensure frame delivery to the monitor remains perfectly synchronous and uniform. The impact on network latency, the network adapter pipeline. It says here, your network interface card handles thousands of incoming packets fragments per second when playing fast multiplayer games. To process these without lag, the network card relies on 2 core files in the Windows kernel, which is ndis.sys, network driver interface specification, and tcpip.sys. And it shows you here, for example, incoming packet from a network congestion path, high DPC. It goes from an incoming gaming packet, goes to the NIC interrupt, stuck behind CTFMON buffer bloat delay ping. The elite path with the low latency without CTFMON working, incoming game packet goes to network NIC interrupted, instant CPU processing, immediate hit registration. Now, the deferred procedural calls queue when a packet hits your Ethernet port. The network adapter fires an interrupt. Windows schedules a DPC to process that packet data. However, the Windows DPC queue is a single line, first in, first out per CPU core. If CTFMON and its deep registration hooks are consistently flooding that same CPU with input monitoring data, your network card's packets have to stand in line and wait. This causes buffer bloat and bullet registration, etc., etc. And I'll let you read this on your own, but this is what happens. By collapsing the parallel input path, you aren't just saving a few mouse microseconds, you are cleaning the entire system queue so your graphics driver and your network card have an entire clear runway to pass data back and forth instantly. And that is the gist of why 2 files cause a complete PC bottleneck for your network card, for your video card, for your monitor, for your RAM, for your hard drive. Everything gets slowed up because of these 2 files. Now, I know I ran this a little long and I have kept LatencyMon open for 26 minutes now. As you can see here, this is not just a 5-minute run, but almost a half an hour I've been keeping this on. I have edited this video multiple times with this still running. As you can see, with this running, this is the kind of latency I'm getting with those files removed. Now, it's kind of hard for me to show you the files removed because all I'll be doing is showing you a task manager with every other file except for the 2 files that should be in there, which is CTFMON and TextInputHost.exe. However, they are removed. Your results are going to vary. I can definitely leave a description of how to remove them through the task scheduler, reboot, and then manually remove the TextInputHost.exe by right-clicking on it and just telling it to stop or disable, and see for yourself if LatencyMon reduces the latency based on your prior LatencyMon results, just a reboot ago. You will see for yourself how low the latency goes. Now, it does vary depending on how many processes you have running in the background at the time you're using Windows, and also depending on whether you're using Windows 10 or Windows 11. Windows 11 seems to be a little bit more processor heavy than Windows 10. With that information said, you can see here for yourself that I have absolute control over my latency. I will show you another example of that using DPC Latency Checker. As you can see here, I'm going to start it up. Without using set timer resolution from Intelligent Standby List Cleaner, which I'll put up in a second, you will clearly see that I am usually below 0.5 milliseconds of latency, which typically would be at 1 millisecond. Why is it 500 less? Because it's 500 less latency being accumulated through CTFMON and TextInputHost.exe. So now, even though I request 1 millisecond of latency to show me the results is doing 500 less, is because I'm doing 500 less of additional power needed for the CPU cycles to lower the latency. That means that the CPU stays cooler, the CPU is doing less work, and I don't need to constantly keep calling in lower latency because the lower latency is already there. Now, that may ask you this. Well, what if I want to find out how low can it go? Let's see for ourselves. We're going to add Intelligent Standby List Cleaner. I have it set to 5 something, some random number, 0.5 milliseconds of latency. Let's start it. Let's first purge. I always like purging. And let's start it and see what happens. Where does it go there? Now the system is only asking for 0.512 milliseconds, but yet its response is 47 to 79 US. I forget what that stands for, but it's asking for infinitesimally less than what I'm requesting because the infrastructure was always there to do so, except for 2 freaking files, creating an unburdened level of latency throughout the entire system. That's what you need to understand. The entire PC system was hinging on 2 files, CTFMON and TextInputHost.exe. As you can see for yourself, I'm asking for 1 resolution. The system says I can do lower than that and then produce even lower than that. 41, what that US is, I forget what it stands for, but whatever that is 1,000 times lower than what I asked for. I just need you to see when I really tax my PC, what it can really do as far as latency. Now remember, I've had this on for 30 minutes already. 30 minutes. I have edited this video a couple of times, leaving this on because I wanted to show you that this is the Super Saiyan 3 ultimate way of fixing the resolution and issues found in Windows, whether it be Windows 10, Windows 11, it's got to be the same, but it ultimately asks the question, what is the real purpose of CTFMON and Text Input Host? Because the whistle was blown years ago, in I believe 2019 or so, that this was a huge security risk and it could allow someone to gain access to your PC through the text host command. So if that was found out and it was doubled down to include it in later versions of Windows, what is this process all about? Because it certainly is not about alone the input text to search for something in the lower left-hand corner or center of the screen, depending on Windows 10 and Windows 11. And it also has more to do with being able to give dictation because you can find other apps to do that with. This was a dual purpose, fundamentally flawed programs that are running in Windows that are causing an insurmountable amount of latency that does not need to be because it's doing something that to this very day in 2026, we don't really know what it's doing. Some say this is just a rootkit or malware or a virus to send data to Microsoft about your habits. I don't know. I'm not saying that. All I know is this is what happens when you have these files installed and working, and this is what happens when you disable these files and take them out of the equation. Lower latency. I would suggest you do the same. How I found out about this and how I know that this works is a direct result of me playing Miss Pac-Man. Not Pac-Man. You had to have very acute ability for hand-eye coordination because the game ran faster than Mr. Pac-Man. Let me show you. But before I do, I'm going to stop it at 33 minutes because I want to start Pac-Man fresh without it having an effect on this result. So I'm going to see if I can bring Miss Pac-Man up and start it. It's not going to be a full screen, but you get the idea. I had fundamental problems playing Miss Pac-Man because I could not control the very start of it when I wanted to go down here. I always missed this. And I had noticed that I could not always get it to go exactly where I wanted it to go. And as you can see, although this is hindsight 2020 and I can't really show you latency differences, I have fundamental control over this game. Now, I'm not trying to run from the ghost. I'm just trying to show you control. If you ever want to find out how good your latency is, play Miss Pac-Man. You will find out real fast if your keyboard and mouse or your controller that you're capable of handling the movement speed of this game without feeling like you told it to do one thing and it did something else. You can clearly see that I'm able to get away from the ghost. It was very hard to get past the first level. As you can see now, it's very easy. And I'm not doing this to be, saying that I'm better than anything like that. It was just difficult. It was easier on the console, but it was very hard on the PC and I couldn't figure out why. So there's that. Now, this video is months in the making. It took me a while to gather the information, put it together, give you examples, show you how the latency is lower, play Miss Pac-Man for you, trying to figure out what game I could use to do it for you. I use Miss Pac-Man as my litmus because Miss Pac-Man, even though Pac-Man wasn't a problem, Miss Pac-Man was. For some reason, I couldn't understand why I had input latency. So I was buying these controllers that were $100. I was trying to get the lowest latency controllers, thinking that the controller was the problem, but fundamentally the problem was the two files encompassing complete and utter watch guardian control over the entire PC latency process, which, I'm trying to stay calm, seemed to be a fundamental flaw as to how this is supposed to work. I personally believe that the people who did this may or may not still be working at Microsoft. I believe that these individuals may have done this with other individuals not knowing that this was a problem. I think that they need to be internally investigated, and I think that they need to have the police involved to find out if this is genuine sabotage, espionage, sabotage, for whatever reasons that these files were supposed to do, whatever it is they're supposed to do. I don't know what they're going to do. I'm not going to speculate on what these files are supposed to do. But it definitely was more involved than just being able to type text in a box and dictate. So I do thank you for your time. Have a nice day.